All right, Brandon, we got, did we change this for him? Do you remember if he heard saw that part?
I think he did.
Okay, so we're starting with velocity equals velocity at time 0 plus AT, and we're doing the example on the sheet. So showing that again, since he might be watching it tonight and not have the sheet. You can pause it and read that example to yourself.
Here, I'll zoom up really close to that. Yeah, I think that's pretty legible. Alright.
Zach, yeah, erase that. Good. You got it? Okay. So you can see that, and now we just plugged in the numbers from the equation. A was negative 2.3. Here's a picture of it. You always draw a picture. And time, and final velocity, since it stopped, was 0. So we just plugged everything in and solved for the unknown, velocity initial, and then used 2 significant digits as the problem pointed us to do. 35 meters per second. All right, that's how you use equation number 1. We're going to develop equation number 2 now. Could you also just erase that? I'll put this one up in the corner for safekeeping. I'm very attached. I get attached to my equations. All right. I want you to start with the same equation that Brian started with, way up here in the left, and write kind of small. You're going to need a little more space than Brian did. V equals change in x over change in time. And we're going to take some liberties with that. Underneath it, instead of calling it V, we know we're always using a period of time. So we can also call it an average velocity. So would you call it V sub AVG, so it looks like an average. All right, so you see how we're just renaming it because we know every velocity we look at is an average on a real problem, unless we're looking at a graph. All right, so velocity average equals, and instead of change of x, we're just going to call it x over t. We're going to assume that the time and the initial position is 0 to simplify. All right, now keep that on hold, and underneath of that, we're going to write velocity average another way. So if you would write velocity average, can you see that? Is it picking up here or zooming in maybe?
Yeah, it's zooming really far because it's so small.
It's good, you're going to need to be small. Velocity average equals, see if this makes sense, if we have 2 velocities, a beginning and an ending, another way to average them is to add them up and divide by 2. So if you would call it V sub O plus V over 2. Now keep up with him, you're writing this down as you go, as he goes. He's on the 3rd step, you can catch up. Are you writing it down? The development? Where's your paper?
It is in the paper. Copying. You done copying?
What were you doing for him? Oh, you were copying your work down, were you?
I was just trying to see if my answer was correct.
All right, notice, I like that. See the steps 2 and 3 both equal velocity average. So when 2 things equal the same thing, we can make them equal to each other. All right, so take x over t and set it equal to V sub O plus V over 2. All right, Zach, I want you to solve that for t once you get it there.
Wait, you're going to do the x plus
No,
t over 2?
see, this is equal to this, so I only need this equal to that because they're equal to the same thing. So x over t equals this. X over t equals V sub O plus V over 2.
Well, what does it say?
Now we're going to, you can see, we have to watch the video tonight.
Yeah.
All right, go ahead and solve that for t. So you can cross multiply. It's a proportion, so cross multiplying works. Are we timing this? No.
Yes.
Oh, you are. Good.
I started a little bit late.
That's all right. We'll just keep that in mind. All right, 2x when you cross multiply. 2x. Oh, you got that? Oh. All right. When I'm at cross multiply, just a quick error. 5 minutes. What? Wow. Oh, you got it. All right. 2x equals t, and you can put t times that. Remember how proportions, the mean equals the extremes, whatever's here times whatever here equals whatever's here times whatever's here. Alright, so distribute your t. We'll finish this one equation and we'll pick this up tomorrow. You'll have one homework problem to do. Alright, so now he distributed the t's. Let us then, see where I am. Let us, I'm kind of lost. Solve for t, you did that. Alright, let's solve for t. Alright, I like it better here. That's what I should. Solve that for t. So, I went one step beyond what I should have. It mathematically sound, but it doesn't help us solve for t. So t equals v sub o plus v over 2x. Alright, now that is totally upside down. Why is that? X over t equals v sub o 2.
Well, you want t.
It would be 2x divided by
over because you have to go to the 1. Like when you do it, you're dividing by t, so it'd be 1 over t, and so then you have to flip it.
Okay. Alright. Alright, so, alright, now we're on track. Alright, so get rid of this one. It's kind of confusing. Alright, when you solve for t, this ends up underneath of that. Alright, that's not the equation, but that's the stopping point at this point. Let's go ahead and, this equation is only partially developed, so we're going to stop there because we're running out of time and I want to explain the homework. So Brandon, put that on hold, add that to your notes, and tomorrow Zach will come up and finish this equation. This is a longer development than the other two, so Zach, thank you for working with us so willingly. Alright, on your paper I hand out, there is a homework problem. It's coming now. It's on the back because these, let me give you all the papers so you'll just have them. This is the second one on day 1. Two. Put this behind the one I already gave you. Behind. Do you have your notebook, Alex? You can stick it right in?
Yeah.
Okay, good. Alright. No, it's not.
No, it's not.
That's not the homework. That's just getting ready for getting all your papers. This has the homework on the back of it. And it's only the one problem that involves the equation that we completed. The one, we'll call it Brian's equation. I'm very attached.
You want this one?
I want him to know what the homework is, yeah.
This is
Alright. Oh, no, on the back of the last paper. Oh,
nothing.
never mind, I couldn't make two-sided copies, so there must be another paper. Yep. So I still haven't got you the homework, but you've got all the papers. Here is the homework, and it's only 2.1, the first one, because that's the only equation that we've learned so far. The one in green up in the corner. Circle 2.1. It's your only problem to do. All right, put this on the last part of your, behind all the pages I gave you. Put them in the book in the order that I gave you. And let's show Brandon the last, can he see that? All right, it's this problem. And it uses the I'm very attached equation. It's your only assignment.
Okay, I think I got it.
Okay, we're halfway through equation number 2. I hope you'll be able to sleep soundly and not worry or ponder about it too much. So, straighten up your area, and we'll be back at it tomorrow.
You want me to turn it off?
Bye, Brandon.
Bye.
Get in here.
Subscribe
See you
to the
later.
video.